Okay, I wanted to start off by talking about the parable of the five talents in Matthew 25. An odd connection, I think, for when we're having a look at God is light. But I wanted to sort of have a look at how the discoveries that have been made by the human race, bit by bit, help us to understand and give us an advantage over past generations and helps us to understand sometimes what's meant in the Bible. In Matthew 25, we know the story. Jesus says one servant was given five talents, another one was given two talents, and another one was given one talent. And we often look at this as an interpretation, meaning that some people have got great abilities, some people might have inherited wealth, and they might be able to use that in the preaching of the gospel or the help for the church. And other people get less abilities. And then finally, there are people who've got very few abilities, but every one of us are expected to use those to our greatest extent. And we normally look at it as individuals and how they vary in the abilities that they've got. But I think there's another way that we can look at it. I'm not saying that first way is wrong. I'm just saying there's another way that we can look at it. And that is that there's a whole group of people who got five talents. There's a whole group of people who got much more than the rest of us in terms of ability. And those people were the first generation, the apostles. They received the Holy Spirit. Where's faith when you see Jesus Christ raised from the dead? Where's faith when you see him taken up to heaven and spoke to angels? Where is faith when the disciples received the Holy Spirit and could cure the sick and could raise the dead? Those people had a huge advantage, and largely, from what we read, they used it. They were fearless in their preaching of the gospel. And all of that was because they were given an enormous amount of advantage by God. Then I'm going to look at those who got one talent. Just imagine somebody who was born in the Middle Ages, somebody who lived around about 1200 AD. They had nothing but their Roman Catholic priest and the stained glass windows of their church. That's all they had. And yet they could still cling to Jesus, even with that amount. And I'm going to suggest at the moment that those people with two talents are us. We have got more than those people who lived in the Middle Ages, not as much as the apostles had, but we live in an age where we are hugely blessed in our Bible study because of what's been discovered in the last maybe 200 years. There's a couple of things that I reckon have been of huge value. The increase in human knowledge that we've had in the last couple of hundred years. I can recall, not personally, but I can recall from writings that archaeologists and people like that back 150 years ago said there was no Abraham. Abraham was just a fictitious figure that was made up by the Jewish people to give them some sort of pattern for their life, to give them something to sort of believe in, a bit of a Camelot for the Jews. Then in about 1860, the cities of Ur and Kish and Urek and Lagash and those places were discovered. And all those cities that are named in the Bible were discovered. And the people that were, well, who told us that they were only fictitious, then they obviously had to eat their words and say, no, they really were places. But there was a 1,800 years of people before that who never knew that those places were provably existing and were true. And we ought to be gratefully thankful for what we have got. We just take these things for granted now. But they only exist for the last 200 years or so. I think I can recall, maybe not, lots of things I can't recall these days, but there was an argument that there was never ever King David. King David was just like a Robin Hood figure. He was just made up, one of those characters that you put into folklore, make people feel good. And I think around about 60, 70 years ago, they dug up a obelisk and the house of David was named by the Syrian kings. And so again, they had to eat a bit of humble pie and say, oh, well, yes, there really was a King David, but he was just a warlord or something. But all of these things are advantages that we get. We get all these advantages that were not available for the last 1,800 years. when we did the little talk on what was it, Genesis, we talked about zircon crystals being discovered in the last 10 years that prove the first two verses of Genesis is true. I find that mind-boggling that you can prove that 4.5 billion years ago, the Earth was exactly the way it was described in Genesis. That's only happened in the last 10 years. And this is something we ought to be grateful for, hugely grateful for, that we have these things that can bolster our faith. My favorite one, as you all know, is first order differential equations in Genesis, exponential decay. I've done that over and over, so I'm not going to talk about it again. But again, that's only available to us now. You know, we can drag it into AI and we can make it draw graphs and all sorts of things. And all of these things are available only in this generation. And I think we ought to be greatly thankful for it. So tonight we're going to have a look at light. God is light. We're going to see that over the last maybe 100 years, we've had a completely different understanding of light. It's going to be a little bit sciencey, what I'm going to talk about, but I hope that you'll see that actually as it unfolds, it actually reveals to us a great deal about God, which generations past would never have known. 1 John 1 says, God is light, there's no darkness in him. And we know that he wasn't, John, the writer, wasn't talking about the reality of what light is. He was just talking about as a spiritual concept. God is open and the openness is there for everyone to see. There's no darkness, nothing's hidden. The plan of God is open to us. Okay, but that's not the only time the statement God is used. I'll just have a quick look at the others. There's the first one, this one that we're talking about tonight. This is the message which we have heard from him and declare to, I'm going to move my little tiles to you. Now they won't move. That God is light and in him there is no darkness at all. We're also familiar with it being called God is love. God has been, again, by the writer of 1 John, he who does not love does not know God, for God is love. So God is light, God is love. These are all different characteristics. I have a very good Christian friend who tells me that God is love, and if you take away love, there's nothing left. Well, that's not what my Bible says. Because here's the next one. God is a consuming fire. I'm going to get my little laser pointer, if I can, get it going. Yeah, down here. God is a consuming fire. What we've got to do is to remember, don't cherry pick your verses. Don't just say God is love and stop there. Go to everything the Bible says. It's what happened when Jesus faced the tempter, who quoted one verse at him, and Jesus said, no, go to the whole Bible and put it all together in a sort of a connected picture. Yes, God is light. Yes, God is love, but he's also a consuming fire, and there is time for judgment. So all of these things give us characteristics of God. But what is going to be really, well, I find exciting, I know I'm weird, but I find these concepts of light exciting. It's going to be, as I said, a bit sciencey, and it's going to, I hope, challenge your common sense. I hope that by the time we finish, your head will spin. We'll see how we go. Okay. All the famous scientists were fascinated by light. It's really odd when you look through the most famous scientists the world have known have always been fascinated by light. You might look at this guy, and I've listed them. I've got 3 of the most famous scientists listed sort of in their order of greatness. It's roughly a consensus. You might find some people disagree, but they're wrong. So basically, this is the list that I think are the great scientists. You might see people say, oh, Charles Darwin's number 1. Well, all I would suggest to you is go to Charles Darwin's book, which he wrote on the origin of species. Turn to page 100, and a 5-year-old child could read it. Turn to page 100 of Newton's book, of the Principia, and you need 4 years at university study to understand the first few words. Tells me which one's the brightest. But anyway, Dr. Einstein spent his life, or I should say Einstein, because he's German, and I should try to practice my German. So he's Albert Einstein. And basically, he was fascinated with light, and that's what led him mostly into all of his scientific discoveries. Often we think of him as being the father of relativity, both special and general relativity, which he was, but he actually got his Nobel Prize by studying light. He got it by understanding the nature of light, and that's why he got his Nobel Prize. So must have been important. One little side light, I always like to have a little side directions here and there. Rather like this picture. Einstein met Charlie Chaplin. And Einstein said to him, "What I admire the most in your art is the universality. You don't say a word, but the whole world understands you." "True," answers Chaplin, "but your glory is even bigger. The whole world admires you when no one understands you." And that is pretty much a description. If you ever look at Einstein's equations, when you look at them, there seems to be only one. There's not. That one contains what are called metric tensors, and those will break down into 16 different equations, 4 of which are redundant. So there's 12 equations, of which almost no one can understand. And as Charlie Chaplin said, everyone admires you, but no one knows why. Okay, if I put Einstein as number 2, who do I put as number 1? I'm not going to ask you to yell out, but I reckon if you can't think of it, you'll see as soon as I say who it is. And you'll all recognize him straight away. Probably the greatest scientist of all time was Isaac Newton. Again, it depends upon opinions, I guess, but it's pretty much a consensus. We're very familiar with him introducing mathematical concepts into science, and his most famous, what you'd say, seminal treatise was this book here, Mathematica Principia Naturalis Philosophy. We normally actually say it backwards. In English, it would be Mathematical Principles of Natural Philosophy. Natural philosophy is what they used to call science back in the good old days. He wrote it all in Latin because Latin was the common language. Every educated person had learned Latin and classical Greek. And so if you want your book read across the world, you wrote it in Latin. But less is known that Isaac Newton also spent a great deal of his time studying what he called optics or light. He was the first one to actually prove that white light could be broken up into colours. Before that, people thought that if it passed through glass, the glass actually altered the light. But Newton showed that that wasn't true, that the colours were already there, and all the light did when it passed through glass was just dispersed into the separate colours. As bright as he might have been, he did some crazy things. He stuck needles in his eyes and peeled back his eyelids and all sorts of things to try to understand how light was visualized, stared at the sun. Well, he didn't end up blind, but anyway, there you go. So he's number 1 in my book, the sort of the founder of studying light. And then after that comes Einstein. Now, who would be number 3? This will surprise you. It's John Thomas. No, I lie. It's Professor James Clerk Maxwell. It just looks like John Thomas, that's all. We've gone from 2 famous people. If I say Einstein and then I say Newton, you all know them, but almost no one would know James Clerk Maxwell. An absolutely breathtakingly brilliant scientist, but he was at the age when mathematics made its inroads. And again, when you look at what he wrote, you can barely understand it. But he would be the 3rd one. Very humble man, very, very humble man, and by all counts, a very lovely human being. Died relatively young, I think, maybe in his 50s. Had a very humble little grave somewhere in Scotland. Compared to Isaac Newton, I don't know if anybody has ever been to Westminster Abbey, but Newton has his own little grave, not little grave, big grave with statues and all sorts of things in Westminster Abbey. But Maxwell, just a little humble grave in a churchyard. Okay, I'm going to have a look now at how they viewed light. Newton looked at light and said it's a string of particles. In those days, it was called corpuscular. A corpuscle just means a particle. So Newton thought that light was a string of particles. Maxwell I'm putting them in the order of appearance, by the way, now. I've gone 1, 3, 2. The 1, 3, 2 is order of greatness, but the pictures here, Newton came first, Maxwell came next, then Einstein came after that. Newton thought that light was corpuscular, that is, that it was made of a string of particles. Maxwell thought that light was an electromagnetic wave, and Einstein said that it's both a particle and a wave. And what we'll do is have a quick look at why Newton thought it was made of little particles. Before Newton, people had suggested that it was made of waves. But there's one thing that Newton noticed about light that to him proved it couldn't be a wave. And I'll just draw a very quick picture here of water waves passing through an opening. Now, you'll be familiar with this. When water waves pass through an opening, they don't go straight through with a sharp edge stopping where the edge of the barrier was. They curl around the edges. Just imagine this is Sydney Heads. And just imagine you've got a stormy day and the waves are coming straight through. They're coming straight through the heads. This is Manly down here. Is the water at Manly completely flat like a mill pond? No, of course it's not. The waves are curled around the edges. It's not as rough. Most of the wave goes through straight off, but this part down here, the waves are still there. And Isaac Newton said that doesn't happen with light. If you shine light through a hole, you do not get the waves curling around the edges. And therefore, light cannot be a wave. Okay, we'll come back to that. The very, very first person to make a reasonable effort to explain what was happening with light was a guy called Huygens. We still teach this to kids at school. We still teach them what they call Huygens principle. And he said, if there's a wavefront, well, it doesn't matter whether it's light or whether it's a water wave, every point on that wavefront acts like a little source of waves. So every one of the old wavefront acts as if it was a new little wave starting off. And when you add them all together, it forms a new wavefront. So Huygens said it's a wave. Newton comes along and says, no, it can't be because it doesn't diffract. It doesn't spread around the edges of an opening. So Newton said it was like a billiard ball. It was made of little particles. And he had good reason for saying that, because light bounces off exactly the same way a billiard ball would bounce off the cushion of the table. It goes in and comes out at exactly the same angle, which light does. But along comes a guy called Thomas Young, 100 years after Newton, and he said, Newton made two mistakes. The first one was that he assumed that light was made from one object just giving off regular waves of light like ocean waves. And he also assumed that the whole was about the same size as the wavelength of light, and that's why it didn't diffract. This guy said, no, what's happening is that millions of atoms are giving off little bits of light and they're all getting mixed up. So when the light comes off a light bulb, you've got millions and millions of atoms and their crests and their troughs are all on top of each other, and it's just a higgledy-piggledy mess. So what he did was to make a very tiny slit, and he figured that the wavelength of light may in fact be very, very small. So he made a slit no bigger than a cut made with a razor blade. And then, according to Huygens' principle, we get a new source of light waves starting from there, and that is called coherent light because they're all in step with each other. Then Young made these two little slits here, and very tiny, so that they were comparable to the wavelength of the light, which he was guessing. And when they spread out, they all overlapped each other and formed what's called interference pattern, light and dark bands. This is a water wave doing the same thing. If you have two sources of water wave, where a crest of a wave corresponds with another crest, you get these bright spots. But where a crest coincides with a trough, you get these shadows or these dead spots in here. And so he was able to prove that what Newton got wrong was that the wavelength of light is so tiny that we weren't able to notice the diffraction. Now, here's why Maxwell is quite not as famous as the others. See how the others can be formed in little pictures? Well, here's Maxwell's pictures. And I don't know whether you can understand it. But they have been a consternation to many a second-year physics student, I can tell you. This was a set of equations to describe electromagnetism. Maxwell had no idea it was connected to light. He wasn't looking at light at all. He was just studying electricity and magnetism, and he came up with this beautiful set of equations. He was actually helped a bit by another guy called Heaviside, who actually helped him with a bit of the what's called tensor algebra. But they put that in to their little equations, and they solved it, found that the answer to these equations is a wave. But the thing that shocked the world was that when Maxwell calculated the speed of this wave that obeyed these equations, the speed of that came out to be exactly the same as the speed of light. The speed of light was already known. And when you solve these equations, you get a wave whose speed is exactly the same as the speed of light. And what that proved that we never ever knew before, light is an electromagnetic wave. It's a wave coming from electricity and magnetism. And so that was really the crunch that got people going to really understanding what light was. Next in our row of scientists comes a guy called John Poynting, and he said that light was made up of an electric field or an electric force vibrating up and down in a wave pattern, a magnetic force that vibrates at right angles to the electric force, also in a wave pattern, and they were moving at right angles to both. So that was the picture around about the beginning of the 1900s. And everybody thought that was pretty good until we came to this guy. And as I said, Einstein, it was his Nobel Prize. He was actually able to prove that by shining light onto a polished zinc surface, it could eject electrons. And that actually meant that the light must carry momentum. You can't knock a particle out without carrying momentum. And the only way you carry momentum is it has mass. It must be a particle. So light must be a particle. So we're back to Newton again. Lastly, we come to this guy called Niels Bohr, Danish physicist, and he explained where light came from. He was saying atoms are basically made up of a nucleus in here, and then we've got these rings where electrons are allowed to go. It's not reality. That's not really what happens, but it was a good enough explanation. And he said the way light is emitted from an atom is that it can drop from a higher orbit down to a lower orbit. And this solved the reason about why we get light from incandescent gases. If you light a candle flame, why do we get light from a candle flame? Because all the little atoms are being heated up and electrons are jumping up to higher levels and dropping down again. And that's how we get light from a candle flame, etc. I'm going to be a bit of a contrarian here and put in one thing just to let you know that this picture is what's called a classical picture. It sort of relates to reality, but in reality, nothing in the atom relates to reality at all. We just cannot understand what's going. And I'll give you an example of that. The electron here drops down to a lower level and it gives off what's called a photon of light. One little unit of light is called a photon. But here's the killer. The electron cannot exist in between these two energy levels. When the electron leaves here, it disappears from the universe and it reappears here. Now, if that doesn't boggle your mind, I don't know what will. It just disappears and turns up again, and that's the sort of thing in quantum physics you have to live with. Now, we are going to soon start to move into areas which will challenge our reality. One of Einstein's favorite sayings, or most famous sayings, I should say, is that common sense is a collection of prejudices acquired by the age of 18. In other words, do not trust your common sense because it will lead you astray. Common sense doesn't work when you get down to the level of atoms. Einstein has been credited with many, many sayings I'm sure 90% of which are rubbish. People just make up sayings and said Einstein said them, and most of it's not true. You might have heard this one. If you can't explain something to a 6-year-old, then you don't understand it yourself. That's rubbish. Einstein never said that, and it's impossible. I can tell you now, if you have a look at the Einstein field equations for general relativity, you can't explain that to a 6-year-old, and you can't understand it yourself. But people just make these things up. Here's a list, which I've got here, of things which in times past, people thought were just common sense. Go back to Bible times. Mental and neurological diseases was caused by demon possession. Of course it were. You've got a person who's perfectly sensible 1 minute, and the next minute he throws himself into the fire or falls into the water or goes mad, foams at the mouth. What could possibly be the answer except demon possession? That's common sense. Just plain common sense. The Greeks had a theory of sickness that depended on 4 humours: blood, phlegm, yellow bile, and black bile. And any sickness was caused by an imbalance of these fluids. Proof? It's just common sense. You don't need proof. That's just common sense. In the Middle Ages, the way to get your humours back into balance was to let out some blood, either with leeches or cut. Why would that help? It's just common sense. That's it. Why should we be any different? Why should we be the only generation in history where our common sense is perfect and never wrong? I'm going to show you in a moment that our common sense cannot be trusted at all. Now, we're going to start moving into the reality of light. I'm sure you'll all recognize what this machine is. This is the atom smasher in CERN in Switzerland. It actually crosses between Switzerland and France. It's a 27-kilometer circumference circle, which is underground. And it's particularly made as an atom smasher. They create particles, atomic particles like electrons and photons and neutrons here. Well, not neutrons, electrons and protons. And they're fired through huge magnetic fields, and they go through a 27-kilometer circumference circle. And when they come back together again, they are smashed together. One string of photons is fired in one direction, one in the opposite direction. Whole machine, about 20 years ago, cost about $10 billion. Today, I guess it'd be about $30 billion. Most expensive piece of scientific equipment ever. And when you look at it, and you sort of think, well, 27 kilometers, that's how far the proton travels. And here comes the shock. This equation was developed by a person who basically laid the foundations for Einstein's special relativity. It was, just so I can remember it, coming back again. Yeah, it was an equation developed which tells us how length contracts. The faster you go, the more your length gets shorter and shorter and shorter. It is not an optical illusion. It really happens. So as you run very fast, your 12-inch ruler, your 30-centimeter ruler will get shorter and shorter and shorter. It'll still look like 30 centimeters to you, but to an outsider who's not running fast, they'll see that it has shortened. Okay, when we look at the Large Hadron Collider, the particles are traveling 27 kilometers, but they're traveling at such an enormous speed, they're traveling at 99.99999% the speed of light. And if you put that speed into this equation tells us what the length is. This is the length that we see because we're stationary. These things, if you put that in for V, that percentage, you'll end up getting V squared over C squared is almost zero. The V is the speed that the particles are going. C is the speed of light, and they're almost equal to each other. In fact, this fraction here turns out to be 0.0001. And when you multiply it by the actual measurement of 27 kilometers, it comes out to be 2.7 meters. That proton thinks it's traveled 2.7 meters. You think it's traveled 27 kilometers, but the proton thinks it's traveled 2.7 meters. It's not wrong. It has traveled 2.7 meters before it reaches the target. And so would you if you were traveling at that speed. Just a matter of interest, these atom smashers, they take subatomic particles and accelerate them up close to the speed of light. Can I tell you that every one of us had an atom smasher in our lounge room back 30, 40 years ago, with subatomic particles being fired at the speed of light, or almost? Can anybody press down your spacebar and tell me what it was? It was your TV set. Your TV set has an electron gun at the back. This is the old, what they call CRT, cathode ray tube. It gives off electrons, and while you're watching it, those electrons travel down at almost the speed of light. Okay, let's move on one patch further. Let's have a look at what happens to a photon of light. Same equation. Let's see what happens to distance for light. Let's see if I can drag this down. I've just got pictures everywhere. Just imagine we've got a photon from the sun, and it sets out and it travels to the closest star. Our closest star is Proxima Centauri, about 4 light years away. So how far is that for us? Well, for us, 1 light year is about that many kilometers. So that's around about 10 trillion kilometers. So the distance to our closest star is 40 trillion kilometers. But for a photon, remember that's the speed of light. For a photon, the speed of light is the same as this v, its velocity is c. So they cancel out from each other, or they actually become 1. They cancel and become 1. 1 minus 1 is 0. So the distance the photon sees is 0. It's naught. The photon, when it leaves our sun and arrives at the next star, has traveled 0 kilometers. Photons don't experience distance. That means they're outside of space. They're outside of space and they don't feel distance at all. They don't experience it. And here's the last one. What happens to the time it takes for the photon to travel? If the photon travels what to us would be 4 light years and takes time, if you put in the v squared and the c squared as equal to each other and they cancel and multiply across, you'll find the photon time is 0. It takes no time for the photon to travel from the sun to our nearest star. It takes no time for the photon to travel from the Big Bang 13.8 billion years ago. No time for the photon to travel to us. A photon that hits your eye, to it, in its measurement, and this is not a fudge, it's not that the photon thinks there's no time passed, it really has no time passed. And suddenly you start to realize, what are we starting to get a picture of? We're starting to get a picture of no time, past and present and future is all the same, no space, outside of space. Can you see where we're headed? We're headed to God. God is outside space and time, and God is light. Now, I'm not suggesting 1 minute that the writer of that letter, that epistle, was trying to hint at this. But I'm saying because our knowledge has increased, we have got this marvelous way of being able to say, look, this isn't showing God's wrong. It's not showing religion's wrong. It's not showing our concept wrong. It is telling us that the most sophisticated modern science is telling us that, yes, photons of light do exist outside of space and time, just like God. This is the message which we heard from him and declared to you, that God is light, and in him there is no darkness at all. If we say that we have fellowship with him and walk in darkness, we lie and do not practice the truth. If we walk in the light as he is in the light, we have fellowship with one another, and the blood of Jesus Christ, his Son, cleanses us from sin. The author of this letter is talking about God light as being his openness, his willingness to share everything with everyone. He's not talking about what we've just talked about, but it still fits in. God knows everything. He's can fill the universe, fill space. He's outside of space and time. And for us to say an electron dropping from one orbit to the other exits the universe, well, that's God's outside, that whole and inside, but he's looking over the whole universe from beginning to end. This is a symbol that Christians often use of God, and I think I sort of like it. I think Stan Dawes was the first person that used this that I can recall. It's got nothing to do with monkeys. It's supposed to be a parade. There's a parade passing by, and you and I are watching the parade. We're watching it, and all we see is what is immediately happening. This is like time. All we see is an instant in time. We see whatever this monkey thing is passing by. So all these people, they've got no idea what's to come. All they see is what's coming. God is above it, almost looking at time as if he's in a helicopter looking down. He sees the whole parade of humanity. He sees what's gone in the past. He sees what's in the future. So the whole thing becomes an open parade, exactly like a photon of light. It's exactly like that. There is no measurement of distance, and there's no measurement of time. He's above it all, looking down, and can see everything. It's a strange thought, I guess, in lots of ways. Maybe it's too hard to think about too much, but as far as God is concerned, he's still seeing Adam and Eve being created, because he looked down on all of humanity. He looks down on the whole array of life, and he's not bound by time. So he sees Adam and Eve, he sees Abraham, sees Jesus on the cross, all of these things there in front of him. And he sees us down here experiencing one moment in time. And he probably sees that electron that exited the universe as it dropped from one level to another. And the image of light is always captured too in the Bible as being a symbol of God, because when you get to the very end, when you get to Revelation, you read, I did not see a temple in the city, because the Lord God Almighty and the Lamb are its temple. The city does not need the sun or the moon to shine on it, for the glory of God gives it light, and the Lamb is its lamp. And here we come back to the imagery of light again. It's the way the world started. You remember the first creation that God made back in Genesis 1 was light. He said, let there be light. And you'll see atheists whinge about that. They say, oh, we hadn't created the sun yet. And if you can't create the sun, you can't have any light. Well, that's just rubbish, because God himself is light. God himself can create that light. And that's the way the world ends. That's the way we get to the end of the Bible, is that light is sort of what outlasts everything else. The Lamb and God, they are both the light of what everything is in that final event. Revelation 22, there will be no more night. They will not need the light of lamp or the light of day, for the Lord God will give them light, and they will reign forever and ever. And again, there's this emphasis on light, right to the very end of our image of God's interaction with the world. There is this image of light. And I just think it's extremely fortunate that we're in an age where we can look at it, and we can also extract other imageries which would not have been able to other generations. Other generations would never have known that light doesn't experience time, that light doesn't experience distance. These things are only our generation. And the beauty is that it's never in conflict with God's revelation. It's always in harmony. We can look at it and say, yeah, understand that. God is just like light, and he's outside of these limits that we have of space and time. Does make you wonder, I guess, sometimes. God knows the beginning from the end. He knows whether we will be faithful to him. And you'll find some Christians, for some reason I cannot explain, I've been delving into Calvinism lately. It's a very strange form of Christianity. It was started by John Calvin, one of the great reformers against the Catholic Church. but it has some really weird concepts. And one of them is that we are totally predestined, that even before the world was created, it was decided who's going to be in the kingdom and who's not. And of course, that's not true. I certainly don't believe that's true. I believe that we have our free will. We can decide whether we obey God or not. However, God knows. God knows who's going to be in his kingdom. That doesn't mean that we are being predetermined to do it, but he knows who will make the right choices. Okay, so here we are, I guess, sitting back in an age when other people would have looked at this and not seen any of these implications that we can see. I have yet to meet a physicist who sees anything religious in this, but I just think it's quite powerful that the very image that God chooses, God is light, that very image is outside of space and time. Then we come to Jesus. Of course, Jesus is the moral light. It's important again for us to realize that when the Bible talks about light, it talks about the moral light, openness, free to see. Jesus' life was open to all mankind. Everybody could see. There were no dark corners. In him was life, and that life was the light of all mankind. The light shines in darkness, and the darkness has not overcome it. When Jesus spoke again to the people, he said, I am the light of the world. Whoever follows me will never walk in darkness. Can any of you remember what's the only miracle that was reserved for Jesus? Jesus did many miracles. I think I'm right here. I yell out if I'm wrong. But the only miracle that was never done by the prophets, Jesus raised the dead. Other prophets had done that. Elijah and Elisha have done that. Jesus healed sick people. Elijah and Elisha have done that. Jesus healed leprosy, and Elisha did that. So it seemed to be everything except one miracle that was saved for Jesus to do only, and that is to heal a man born blind. If someone is born sightless and lightless, the only way that could be cured is through Jesus. And knowing that Jesus was the light of the world, that was symbolic that he is the only one who can bring us to the light. Okay, so I don't know whether you got something out of that. I sort of like it, but I think it's, I don't know, I find it quite moving that light is outside of time and space, and that's God's representative pattern. And I think that's it. And I will stop sharing, and I'll also stop my phone. Just hang on a minute. That's all right.